everyone. Good morning, afternoon, and good evening, wherever you happen to be, all points global. Looking forward to joining us for this session. This is the Using Open Source Technology to Manage IIoT Edge Solutions track. It's brought to you by IIoT World and sponsored by Influx Data. I'm Greg Orloff. I'm a senior analyst here with IIoT World. And on behalf of our co-founders, Lucian and Carolina, as well as our global team, thanks for joining us today. As a leading authority on industrial IoT, IIoT World is a digital media outlet bringing the latest industrial Internet of Things, virtual conferences, and content to a global community of over 200,000 folks and decision makers, influencers across the manufacturing, energy, smart infrastructure, cities, and buildings. IIoT focuses on delivering daily intelligence on the Internet of Things, artificial intelligence, augmented reality, predictive analytics, digital disruption, cybersecurity, and machine learning. And we're monitoring the online channels today, so please be engaged and submit your questions through the Q&A tab here, right in the Zoom tool. You can also send them in using the social media, Twitter, using the hashtag IIoTWorldDays. That's IIoTWorldDays, and use that across the social platforms. So during this session, we're going to gain multiple perspectives on operating at the edge and learn how open source can be leveraged to manage and innovate at an open edge platform for the industrial IoT sector. We're also going to delve into the aspects of how machine learning is being utilized in the IIoT edge applications, as well as how open source is driving global collaboration for developmental works. Now, our first session, entitled Why Open Source is Key for Innovation in Industrial IoT, will be presented by Craig Hobbs, partner engineer at Influx Data. Craig's experience with keeping systems performant over the years has helped shape the kind of a sales engagement engineer that he is today. And he's one who enjoys solving complex problems and keeping salespeople honest, from his own terms. His specialties include solutions architecture, project management, POC design and development, software customization, technical training, ETL automation, application integration, and deployment. Craig has a BS degree from the University of Illinois. Craig, welcome today. The floor is yours. I'm going to hand you over the controls here and let you walk through your presentation.
Hey, thanks, Greg. And hello and hi, everyone, wherever you are. Hope everyone is well and safe today. So again, as Greg mentioned, thanks for joining. Our talk today is going to be on using open source solutions. And as Greg mentioned, my name is Craig Hobbs. I'm a partner engineer here at Influx Data. And in my role, I get the unique opportunity to work with technology integrations with our partners, with our direct sales customers, and with our user community. So it's really a fun role where I get so many different opportunities in different implementations, different deployment strategies, where Influx becomes the core of a lot of different IoT solutions. Everything from collecting telemetry data from an autonomous car to reports on robots on a manufacturing floor, right down to doing monitoring of devices and sensors deep inside of an underground mine. So many different ways to use Influx, and that Influx is part of so many conversations. I'm really happy with the idea and where we play at. So if you have some questions or you'd just like to talk about some of the different things we're doing, please reach out. We love having conversations, love telling you what's new, what's coming, and some of the activities that we've done. With that, I just want to talk a little bit about what I plan to cover today. So looking at some of the challenges and concerns that we see with working with edge solutions and IoT, some of the conversations that we get into often with our customers. Also take a look at where we see open source innovation and partnering as meeting the challenge for these concerns. So how we've done that and what we've gone about in doing it. And finally, in with some of the solutions that we're working on to date, some of the more recent things that we've done and how they've shaped some of these key deployments. So turning into this, let's get started with what's happening at the edge. So I get brought into so many conversations around our platform, and where I get started is always in the same spot, and that is, can you help us gather some of our data and bring our data and collect our data in our plant and our manufacturing facility in our data center? And my answer is always an immediate yes. And what we're talking about is time series data. So if you're unfamiliar with time series data, it's just kind of a simple just a simple definition, and that is that time series data is a series of points indexed in time order. So collecting that, and that's where influx comes into play as we're able to ingest, query, process all that data at scale. That's really where we wind up coming into a lot of conversations. But what I always like to do is step back and really frame this with customers, with architects, in that it's not just the idea of collecting time series data. It's not just about the data. It's really about the access to the data and providing that access to the data everywhere, providing that access to your operators so that they might make reports and continue and do continuous improvement, receive alerts. It's about providing that access to data scientists for anomaly detection, machine learning, process improvement there. It's about providing that data to your enterprise so that the enterprise can make other funding decisions, other asset decisions. So really moving that data from the edge, there's 62% of the data from the edge to all of the different areas where where readily available access to the data will make for an opportunity. So we see this as an opportunity, and that opportunity is providing that data access. But not just about the data, but also the questions and concerns we get into when discussing IoT at the edge is the complexity. So we're talking about more applications. So there's just so many more applications. When I go out and talk to customers now, I have to deal with all of the different securities, all of the different protocols, all the different communications, just so many more applications. Similar with, there's just more devices. So we're seeing this device growth in the intensification of the physical world. And we're expecting that to continue to grow. And even by these conservative estimates, we're expecting so much more in that area. And again, that creates that level of complexity, both horizontal and vertically. So now we have so many devices running around, and now how do I communicate with them? How do I move that data up into my enterprise? How do I make the best use of that data? And then more competition. I remember when I first started the discussions with lots of IoT customers in manufacturing, in engineering, in aerospace, there was just so much that these are just the larger players. But now what we see every day is that there are medium and small size players working in this same area, working to access this data, working to make opportunities for customers, for end customers, for the enterprise at the edge. So this complexity that continues to grow from it really leaves us with the idea that no one simple solution, no one simple commercial solution solves all the problems. So what can we do? What can we do to meet the vast growing complexity of the edge as it continues to expand? And what I also get into when I get into these conversations is a look at data historians. So data historians are always the table stakes when I walk into a lot of the IoT industrial areas where they have the central processing unit of this operational data historian. And now how can we work with it? How can we help modernize it and patch onto it? And what we're seeing again more and more is just with this complexity, these one single monolith solutions are not enough to address all of the different actions and events that are going on. And that's really where we start to discuss the open source advantage, the open source innovation. And really, I'm turning now from that idea that when these conversations first began, it was always open source was an idea. It was more a niche type of product delivery. But now it's really the norm. The discussions I'm having now is not about our open source can open source handle all of my protocols? Can it handle all of my security? Can it scale? It's now, what is the solution you're trying to get at? What is the opportunity you're trying to make from that data? Who needs access to that data? What level of complexity and scale are you dealing with? And open source is actually at the forefront of these solutions now. So really happy to see that growth and development from setting up open source and moving it through. And with that, what we find now is that open source really is that movement where it is the edge. So when I'm talking to customers now, it's not about just a single commercial solution. It's how can open source address all of these different challenges, attributes, features of what I'm dealing with my solution in IoT. So everything from an outstanding ROI delivery to the idea of time to value. I'm working with open source solutions where we're delivering entire solution sets in a matter of days as opposed to months or even longer with some of the other commercial offerings I often see delivering solution sets there. The ability to interoperate with so many of the different communications protocols, devices that are available now. Open source is an ever evolving set. So where there is gaps, it's easy to fill. Where there are questions, so many times now open source has the answer, and you're not confined to just one open source solution. You can combine up these solutions to really create unique value around your specific question, around your specific questions and the challenges you're working toward. We at Influx, because we do steward an open source project, we really see ourselves as parenting many of these solutions now, along with hundreds of other open source projects. So again, working together to address these types of solutions. So my colleagues are always reminding me that, hey, yes, we're one of the core parents in these solutions. So I always tell them, hey, if I'm going to be a parent, I'm going to be a cool parent. So I want to be the Mac Daddy of open source. And in doing that and kind of bringing that type of leadership to the open source delivery, we really want to showcase how you can operate with Influx and other solutions and solve some of these complex problems. So in taking a look at that, I want to showcase some of the examples of solution sets that we've talked through with some of our more recent customers and that we've shared. And going back to the idea around complexity, I always bring up the idea that your specific use case, your specific open source challenge is made up of a lot of different features. And what we want to do in that complexity is showcase the idea that you can start with what it is that you're looking to do. If that's share your data, bring that data everywhere. What we can do is now start to map those features, those specifics to your use case to individual projects to start to deliver on that unique value. So whether your challenge is with bandwidth or privacy and security, we can now bring together the best of breed of those open source solutions to meet that challenge. So again, not one single solution, not one single commercial solution to try to do everything for you, but let's attack your challenge, your problem from what the unique attributes make it up. And then we can use the various available solution sets to build out something. And in doing that, I like to turn and take a look at some more recent work that we've done at Influx, working with different solutions, working with different problems. So in this particular case, looking at the idea of the complexity and vastness of a distributed system where devices and sensors were going into a mine. So what we needed to do is address the idea of how can we do continuous improvement? How can we do alerting? How can we continue to monitor the various devices and sensors when they will be air gapped from any type of hub or gateway? So with Influx, we were able to actually deploy our software directly onto the devices. So now on the device itself, the data collection and the processing happens. So I'm able to give direct information to the devices as they move inside the mine, as they move outside of the gap. But once those devices come back into range, I'm then again able to collect that data, because again, it's about making sure that data is accessible, collect that data, bring it into a gateway, and roll it up to a larger set, be that cloud, be that some hub, that data can now be shared amongst the enterprise for other deeper insights, other analytical drill downs, downsampling, machine learning, so many other uses of the data. But really kind of solving the challenge of how do I deal with the scale of this issue and the latency between it. And again, open source speaks to so many of the different challenges, protocols, security concerns with this. So this was a great example of how we could use our platform to just tackle this specific challenge. But also, open source solutions can then be combined up. So in a similar way, taking yet another challenge where we're working inside of a manufacturing area and plant floor with lots of different protocols being spoken. So we were able to combine ourselves with yet another open source solution, in this case, using the Apache NiFi project to bring in data from OPC UA while still leveraging Influx to bring in data from Modbus and from other 5G networks that were being deployed inside of the manufacturing floor. But the key being that no one solution was able to speak to all of the different protocols, again, the complexity of the solution. But by deploying and using open source and really focusing on the features and attributes that we were able to bring this together and now make that data available to the operators. So again, data access, data everywhere. So collecting all that data from the wide variety of protocols that were on the manufacturing floor, bringing them into reports and dashboards that operators can use, that they can manipulate, that they can work with, and then finally rolling that data up again to some level of enterprise that they can now do additional drill down analytics and work on. So open source provides just different connection methods that we can kind of work on and move up. So this is really where we see that opportunity again, with combining and working with open source that allows it to extend beyond what you get in just a single package from a commercial vendor, from a commercial delivery, but also opening the doors for flexibility, for cost, interoperability. And I really sum all of these points up to be more freedom. Freedom from being locked into a single vendor, a single delivery, freedom to choose the platform and network and framework that you want to continue to develop and continue to deploy. Freedom to actually have an ROI that's deliverable at a level that you're able to explain and expand over time. So open source really has become that critical component for IoT and edge solutions. So this, and it's this development that we continue to see and grow and push forward with. So as one of the stewards of the open source project. So really happy to continue discussing and sharing more of our conclusions and some of our projects internally. So with that, Greg, I think that brings me to the end. Really appreciate everyone taking a moment to pause and listen. I do, and we'll be here for questions at the end. So back to you, Greg.
Great, thank you very much, Craig. The Mac Daddy of open source. Appreciate the insights. So we're going to move on to our second presentation now. This is going to be by Jim. And Jim is the CTO of IoT Systems. And he's Jim White, I'm sorry. He's going to be presenting using open source technology to manage IoT edge solutions. Jim currently serves as the technical advisory committee of the Linux Foundation, LF Edge project. And prior to joining IoTech, he was a distinguished engineer and IoT platform team leader for Dell Corporation in the Dell Technologies Group. There he created and architected the project that became EdgeX Foundry, one of Dell's largest ever open source efforts. And he remains a member of the EdgeX project, serving as vice chair of the technical steering committee. EdgeX, which is now part of the LF Edge, is an open framework for building industrial IoT edge computing systems. So Jim, please, the floor is yours. I'm going to hand you control here for 1 second and take it away.
Thanks, Greg. Thanks, Greg. And I'm not sure if I'm going to be able to follow Mac Daddy. I guess that means I have to try and make people jump. I'm not sure, but I'll do my best. So let me see here. It says I cannot share while somebody else is sharing, Greg. So I think
you don't need to share. You can just go ahead and use the arrow key, Jim.
Gotcha.
You should be able to advance right through.
Gotcha. Hang on, everybody.
You can do it right on your keyboard as well, if you'd like.
Yep. Well, let's see.
There we go.
There we go. Greg, I think this is somebody else's deck. But there we go. All right, now we're into it. All righty. So thanks everybody. Thanks for the introduction, Greg. Again, Jim White, CTO of IoTech, and formerly of Dell. And I am the TSE chair for EdgeX Foundry, a project that, as Craig mentioned, I think we feel like we have done a fairly successful job in providing middleware that helps to address getting the IoT world out there connected to our OT world. So trying to provide for OT and IT connection through EdgeX. Having said that, what we find is that there is now kind of a problem in another space, and that is what we call edge management. So when you hear that term, it might bring up a lot of questions. Well, what the heck is edge management? There are two terms there, edge and management, that might have some meaning to you, but what do they mean together? as we were building EdgeX Foundry and as we put together our solutions inside of IoTech, once you've got this application, once you've got some sort of mechanism to bring OT data into your IT world, how do you get that solution out there to the edge? How do you plan to get your application to the edge, to your platform, whatever that platform might be? How do you start to monitor and manage that application at the edge? Even in a situation where you may be familiar with various enterprise and cloud computing types of paraphernalia out there, doesn't always work well in these edge environments. So how do you manage the nodes, that is the host computers that are running those applications? How do you manage those applications like an EdgeX? How do you try to address those types of problems? And importantly, doing that, at scale. Sorry, I'm too quick on the trigger there. Because that's the other thing we're finding in this environment is when you're trying to manage, say, a cloud deployment, you're talking about maybe dozens, maybe hundreds of nodes that you have to deal with. When you're dealing with this edge solution, you're talking about literally tens of thousands, potentially millions. We've got one POC where the POC itself, the pilot, is 80,000 nodes. That's a considerable chunk of real estate that you have to get applications onto and then monitor. So how do we do that? Well, we see it as two parts. Edge management, what I call prepping the box, and application management, which is getting the bits to the box. When we're talking about the box in these edge environments, that typically means things like a gateway, an IoT gateway. Not always. There are certain situations out there, you've got some bigger iron out there. You may have something smaller, something the size of a Raspberry Pi, for example. In terms of applications, what I call bits to box, again, we are big fans of open source efforts. So certainly things like our own EdgeX Foundry or other applications you would find inside of the LF Edge umbrella. It also means our own commercial venues, Edge Expert, which is our commercial version of EdgeX, and EdgeX RT, which is a real-time system. It could mean something like Greengrass. We talked to the Amazon folks and they asked us, hey, how do you get the applications to the box? In either case, there are these two big problems you have to solve once you've got an application. How do you prep the box? How do you get your nodes available and ready to receive these edge applications? So how do you get the OS out there, the firmware, all the infrastructure? How do you get your network set up? And then how do you monitor that node? Its level of CPU usage, memory, things of that nature. And on the application side, deploying and orchestrating the applications, but also being able to start, stop, and restart those applications when something like a configuration change has occurred. How do you monitor the application, the data moving through and making sure that your OT data is making its way to the IT systems? And how do you provision new sensors or devices, the actual things out there in this application realm? So two big problems that we face, we think now once we've started to solve the application need at the edge. I jokingly here refer to the solutions of the cloud and using enterprise and cloud technology here. A lot of my coworkers are from the UK, and we talk to a lot of people in the UK. And the solution we hear from a lot of folks is, oh, no worries, mate. We're just going to throw Kubernetes at it. Kubernetes or OpenStack or OpenShift or some other cloud or enterprise tool at this problem. Jokingly, I had one of my clients say, what's the problem? Doesn't matter. Kubernetes is the solution. That sounds all well and good, and we can make light of that. But in reality, when you talk about something like a Kubernetes type cloud-based solution, it may work in certain environments. It may provide you part of the answer, but what you're going to find is it is going to be lacking in a lot of the other areas. In fact, there's a well-known article out there, let's use Kubernetes. Now you have 8 other problems. You'll see that Kubernetes is not always your solution. And by the way, I'm not trying to hammer on Kubernetes. Many of the cloud enterprise solutions that we've seen applied to this space are going to leave you wanting. You will find that you need node and application management. In many cases, the cloud environments are really about getting your applications deployed, not dealing with your nodes out there at the edge. You need to operate across a heterogeneous environment, multiple OSs, sometimes real-time and very small, tiny OSs. You have applications that are sometimes containerized or non-containerized. Many of the cloud solutions are only going to be in a containerized fashion handling your application. And you need to run in on-prem situations at a factory that's disconnected from the internet as much as you need to run from some sort of cloud perspective. And there are unique edge problems that we see out there that you have to address. In particular, when we're talking about the edge, you have to look at, I can get to the next slide here. Sorry, everybody, a little fast on the trigger. My trigger finger is faster than the refresh. When we talk about edge solutions, though, we're talking about resource constraints. A Kubernetes environment needs 700 megabytes of memory minimally to run. Many of these edge systems aren't going to be able to support that. We have to scale again to thousands, hundreds of thousands, potentially millions of nodes, not tens or hundreds. We have intermittent connectivity. By definition, that rail car or that ship that's out there is not always going to be connected, and your edge management needs to deal with that. We have to deal with things that speak protocols that the IT world and the cloud environments out there don't typically speak. And there are security constraints. The data may not be able to leave a particular edge node due to geopolitical types of circumstances. A lot of the infrastructure at our edge is old. OT life cycles are measured in decades. They're not measured in months or years. And again, the heterogeneity problem. So there are a lot of these things about edge management that are unique that you don't find in enterprise or cloud application management. So how do we try to address this? Just as Craig mentioned, we are big believers in the open source realm. We think there are a lot of things we can leverage to help solve this problem. So we're taking some of the cloud enterprise tools, yes, taking that from the enterprise world, but bringing them together into an edge solution, a little bit more of an agent-based solution that helps us provide true edge management, not cloud management tried to apply to the edge. This allows us to get there faster to market. It's providing us an ecosystem to leverage that is huge. Let's face it, things like CNCF are a wonderful community to help leverage some of that knowledge and bring that to bear for this edge market. It's very cost effective to start with the open source effort. And then when we think about operator comfort, the people who are managing these systems, they're already used to some of these edge and enterprise and cloud solutions, things like Pertainer. So we take advantage of those. And we are allowed to use best of breed solutions and swap that technology in and out as we see fit, just like we're doing with things like our EdgeX environment at the application level. So from a perspective of how we've started to tackle this edge management problem, we have a saying in EdgeX Foundry, it's all about crawl, walk, run. Don't try to start running right away. And with our very first look at this problem and our first release, which we are hoping to have out here in the next couple of weeks, again, leveraging open source componentry, bringing it together, providing some basic features of node management, being able to add nodes, remove nodes, being able to get the general status of a system. Is it up? Is it down? What's its memory usage? And then basic application management, being able to work initially with containers with an intention to move to things like non-containerized environments, being able to view the applications that are registered, know that they're up and running, and get an initial status. And we're starting with our own products first, things like Edge Expert and things like the open source EdgeX Foundry. Gathering some metrics on that set of applications that are out there so we know, is it running out of memory? Is it starting to run out of CPU? Things of that nature. And as you can see here with the components we're using, all open source technology, all technology, which again, we have to kind of bring together a bit with some of our own glue code, but bringing it together so that these components over time can be swapped out with best of breed solutions. Now, it's not a perfect world. There are a number of challenges that we've found and discovered as we try to solve real edge management. Scale. When we talk about scale, and even if you look at enterprise and cloud systems that we're trying to use in some cases for some pieces, they do not always have edge scale. Just trying to define all the nodes in your environment is a real challenge. Think about trying to list out all the IP addresses that you're trying to deploy to. If you had to do that and then there were millions, the spreadsheet or the database to do that alone is a really tough problem. So we're trying to figure out solutions so that edge management doesn't become somebody's huge data entry problem as well. The traffic is not in terms of volumes of data, but it's really in terms of the number of nodes that you have to worry about. And how you provision and configure all those is a bit complex. Configuration, we're learning per each node, it tends to be something that you have to really think about at the onset. You can't just deploy an application like you do in the cloud where everything is pretty much generic and every instance is the same. Not going to be the case in the edge. You still need agents. How do we get them there? How do we coordinate with the agents to get back information from those systems? That's a challenge because we are taking a collection of solutions and trying to bring that together. Over time, we expect that to improve. And applications aren't one thing, it's a collection of services. Just like we find with EdgeX, we're a microservice-based architecture, and trying to deploy an application that's microservices gets to have its own challenges that's compounded when we start to go to things like the edge. And how do you onboard sensors? Once you've got your application laid down, how do you start to provision all the things into that application? Again, with all the constraints of sometimes security and networking that apply. The enterprise technology doesn't know how to deal with that. We're having to provide special code to be able to work in that environment. There's a technical debt we're seeing. Edge and cloud solutions are often built for very large, big systems. And so they can gloss over some of the scaling issues. They can gloss over some of the UI issues. They can gloss over some of the problems that maybe are underneath the covers. We find that those warts show pretty quickly when we use them in this environment. And so we're having to try to address some of that technical debt in that open source enterprise cloud solution set. And again, application metrics, how do you collect it? Where is the line in terms of how much data is too much data? What do you minimally need? Because if all those systems start reporting back all sorts of metrics, you become deluged by an information set that you really can't handle. Many of the UIs are familiar, but there are lots of UIs. Right now, a lot of the solutions have their own UI, and we're having to try and bring those together. What we really want is a single pane of glass for the operator. That's going to take some time for us to achieve. So lastly, if I can just make a call that we are looking for organizations to help collaborate with our efforts. This is an issue that we think needs some attention. We're getting to a point where we've got the world starting to be connected from the thing world to the enterprise world, but now how do we start to deploy these things at scale? Come work with us. Look at standardization of APIs. How do you do metrics collection and provisioning at scale? How do you start to bring sensors on board with a common set of APIs? The LF Edge and EdgeX Foundry projects are perfect examples of how we try to bring everything together and start to work through some of those issues, and we welcome that collaboration. Contact me, jim@iotechsys.com, if you'd like to work with us and find solutions to these problems. With that, Greg, I turn it back over to you, and thanks.
Great, thank you, Jim. It was I love the analogy crawl, walk, run, because I think it's one that's very relevant to many things above and beyond industrial IoT. But I think if you start to bite off that apple or that elephant, so to speak, you can't take more than a couple bites at a time. So thank you for sharing that session. We're going to move now to Crosser Technologies CTO, Goran Appelquist. He's going to present his session, Understand Edge Machine Learning Ops, Lifecycle Management of ML Models Running at the Edge. Goran's career started in the academic world, where he earned a PhD in physics by researching large-scale data acquisition systems for physics experiments, such as the LHC at CERN. And after leaving academia, he's been working in several tech startups in different management positions over the last 20 years or so. Goran's passionate about learning new technologies and using them to develop interactive products and explaining how solutions function and work to end users from both a technical and a non-technical perspective. So Goran, I'm going to pass you the control, and please, the floor is yours.
Thank you, Greg. So let's see if I can manage the controls. I don't see any controls actually. There we are. So I will address a more specific problem maybe than the previous speakers, talking about how you get machine learning to run at the edge and how we at Crosser try to help you with that. So quick first about Crosser. We're a Swedish software company founded about 4 years ago. So I'm based out of Stockholm, Sweden. And we provide an edge analytics solution that primarily targets industrial use cases, both for Factory 4.0 applications and for machine builders that wants to enhance their offering by adding edge streaming analytics on top of their machines. So in this presentation, I will talk about Edge MLOps. So what is that? I mean, of course, there is a relation to DevOps, which has been around for many years, and also to the more recent MLOps. But for us at Crosser, Edge MLOps is about simplifying the production machine learning lifecycle at the edge, which is something that many of our customers are struggling with. So if we look at a typical machine learning lifecycle, I mean, there are two two main phases or stages that you always see. The first one is the training stage, which is where you develop the model by iterating over your data set to eventually develop and fine-tune a model. So at the end of this process, you have some kind of machine learning model. And then you can take that to the next step, which is the inference or the execution phase, where you actually use that model and apply it on live data that in our case is coming off the machines. So the training part is typically done in the data center, either on premise or in the cloud, and you operate on data that is stored because you have to iterate over the data set multiple times to develop your model. At the edge, we only do typically the inference part or the execution of that model. And here we use that model to apply it on live data that we get off the machine. So this is streaming data that we get off the machines and have to send it through the machine learning model to get insights and predictions or whatever, and then deliver those results to wherever they are needed. So when we talk about edge MLOps, it's this last part that we mean. This is what it's about, taking that machine learning model that you generated from the training session and make use of that in an edge environment. So what do we need to do to address this part of the problem here? So there are three main areas that we need to address. The first one is to provide an execution environment at the edge. And today that typically means replicating the same framework that was used to develop the model in the training phase. So whether that is TensorFlow or scikit-learn or whatever, you typically need to provide the same execution environment at the edge. In some cases, there are optimized versions of those environments that you can use, like TensorFlow Lite, which would be more suitable maybe for an edge deployment. But hopefully over time, we will start to see more generic execution environments based on some generic model exchange format like ONNX, for example, that was developed by Microsoft and Facebook. So then we could have a more optimized execution environment at the edge, and which is also decoupled from the framework that was used to develop the model. But that is still early stage, and we don't see that as much yet, but hopefully that will change over time. The other thing we need to address is to adapt the environment for that machine learning model, especially on the data. When we get data off machines, it's most likely not in a format that can be used right away with the machine learning model. So we need to adapt the data so that it can be used with the machine learning model. Data from machines comes in formats that in most cases needs to be restructured or reformatted or rescaled or whatever. Since we're dealing with time series data in most cases, we might need to create windows of data depending on how the model was developed. And if we get data from multiple sources, they're most likely not synchronized in time. So we might have to synchronize these different data streams so that we can feed the machine learning model with updated samples that include data from all the sensors that we have independent of the originating source. And finally, depending on the execution environment we use, we might need to do some special adaptations for that as well before we can use the model at the edge. So for example, if we use TensorFlow Lite in the edge, the execution of the model will not be exactly the same as it would be if we use the full framework that was used for training. So there are a number of adaptations that we need to do at the edge in order to use the model there. And finally, it's about deployment. As we've heard in the previous presentations, this is a huge problem. I mean, we need to get both the model itself, of course, to the edge, but also make sure that we have the environment set up. And in many cases, edge means remote. So we're talking about remote devices and not one device. We're talking about many devices in many cases. We want to run, if we're a machine builder, we have the same type of machine running in many places, and then we want to run the same machine learning model in all of those machines. And we want to manage them in an efficient way so we don't have to do one by one updates on all of these identical deployments that we have in the edge. So the deployment side is also an important part that we need to address in order to make this effective. So in the following slides, I will go through how we at Crosser try to address these challenges. So our solution is based on 3 key principles, where the first one is simplicity. Deploying edge solutions, as I think you've seen in the previous presentations, is not a trivial task. And we have really tried to make it as simple as possible, both because there is a lack of skills among our customers. They don't necessarily have software developers and DevOps guys that can manage all of this. So we've tried to make it as simple as possible to get started with edge deployments. And we do that by providing a library of pre-built modules that implements common functionalities that you need in the edge, starting with modules to collect data from the machines using the typical OT protocols that you see in the edge, which you might not see in the cloud. As we've heard, it's a quite different environment. And then modules to do something with that data, starting with restructuring, reformatting, implementing different types of logic. And then eventually you need to send the result somewhere, whether that is to another machine or to some on-premise IT system or up to the cloud. So that's the starting point. But then we also we know that we can never provide pre-built modules for every possible use case. So we also want to provide an open and fully flexible system where you can add your own custom functionality that is lacking from the standard offering by Crosser. And one example of that is that you can bring your own machine learning models, whatever framework or tools that you use to develop that, and then use them on top of our edge solution. You can also run your own custom code and complement the pre-built modules, and you can also develop your own custom modules and add to the library if that is preferred. And then finally, we have also tried to address the scalability and deployment issues that I mentioned earlier, to make it easy to operate also on large installations of edge nodes, so that you can operate on groups of nodes as a single entity instead of having to operate on a node-by-node basis. So we see our edge solution as an integration layer that you can run on the factory floor, close to the data sources, collect data, analyze it locally, and then deliver the result to wherever that is needed, if it's to the next machine or to some on-premise system or up to the cloud. So the actual solution has 2 main components, where one is the node, and that's the software that you run at the edge. And this is a generic software component, so you install the same software everywhere, independent of the eventual use cases that you want to run there. It's typically installed as a Docker container, even though there are some other options. So you can run it on any host that supports Docker, which today means basically everything except maybe microcontrollers. So the Crosser node is where all the processing happens. And then you use the second part of our solution, which is the Crosser Cloud Service, which we host for our customers. And that is where you design the logic and the use cases that you eventually want to run in these edge nodes. And then from there, you manage all your edge nodes and decide where you want to deploy these applications or processing flows that you have designed. And you also monitor your nodes and make sure that they operate as expected, and manage them throughout the life cycle so that you can easily upgrade and introduce new and change functionality over time. And for the actual design of these use cases, we use a standard drag and drop tool where you combine these pre-built modules into processing flows like you see on the screen here. Starting with input modules and working your way through all the way to the output. And you do this centrally in the cloud. And from there, you can also test run these flows with live data interactively, live data that you only have access to from the local edge node. So you can run the flow on any of the nodes that you have deployed in the field and interactively see what is happening with your data as it passes through the flow before you decide to deploy it into a large number of edge nodes. So the way our deployment model works is that a flow is sort of the object that you manage. A flow contains everything that an edge node needs to know in order to run and execute this use case that you have designed. So it's not just the modules and how they are connected that makes up the flow. Everything that is needed around that, like the machine learning file that you need, maybe code files that are used, local configuration of the node, like libraries, machine learning frameworks that needs to be installed before you run the flow. Everything is contained within that flow, and it's then a flow that you deploy to an edge node, and then it knows what it needs to do and set up before it can execute the flow. And you can then deploy that to any number of flows, and they will automatically themselves make sure that the environment is correct before starting the flow. And these flows are version controlled, so you can easily make changes and then roll out the new version to all the nodes that run the previous version with a single operation. So it's very easy to update and also roll back, of course, if you have or see problems with those flows. Another key thing here is that it's not just the configuration of the modules that is downloaded, it's also the modules themselves, which means that you can at any point in time add new functionality into the system by uploading a new module into the central library, which could be done by Crosser or by our customers or partners. And then that new functionality becomes available on all the nodes that you have in the field without having to upgrade the software that runs on those edge nodes. So combining all of this, let's see if I can. These tools means that we can address all of these three areas that I mentioned initially to make machine learning work at the edge. So managing how to get these machine learning models to the edge, making sure that you collect and prepare the data for being used by the models, test running these use cases before you deploy them, and then also manage them throughout the life cycle, because we know that whatever you deploy initially will never be the end story. There will always be updates that you want to do, either updating the machine learning model or improve, add more data sources or send results to other destinations and so on. So you need to have a simple way of maintaining this over time. And I think I skipped that slide and go straight to here. So that's the end of my presentation. If you want to know more, there's a free webinar that you can watch, and also a free training course that you can sign up for and get hands-on experience with using our tools. And if you have questions, then feel free to get back directly to me. I thought there was one more slide. No. Okay. At least you have one email. Yeah, okay, there we are. So if you have any questions, then you can always reach me at this address. Thanks everyone for listening.
Thank you, Goran. You've given us definitely some insight in the machine learning aspects of industrial IoT. Great presentation. And please, folks, don't wait. I mean, if you want to shoot in some questions for Goran, you've got him live here now. So we'll be sure to jump into those later on in the session, in the Q&A portion. So we're going to move now to our final presentation of the afternoon or morning, depending on where you are. This is entitled Uniting the Edge for Tomorrow's Demands. And this will be presented by Arpit Joshipura, who is the General Manager of Networking, IoT, and Edge Solutions at the Linux Foundation. With over 30 years of experience in networking and vast amount of expertise, Arpit leads open source networking, orchestration, edge, IoT, including LF networking projects, as well as major industry disruptions, including BNFs and CNFs, which is cloud native network functions, 5G and AI at the Linux Foundation. He's orchestrated and led many industrial disruptions across enterprises, carriers, cloud architectures, and has been an early and often evangelist for open source. So Arpit, I'm going to turn over the con to you here and let you share your presentation with us.
Oh, thank you, Craig.
And here we go.
All righty, very good. Thank you very much. The title is very important, and we kept it last for the very reason that I want to bring it all together and sort of give you a few ideas on how you can participate. Because open source is all about collaboration, and we got to unite developers from around the world in a community that will simplify and solve problems. So I'm going to make sort of three statements that are relevant here before I get into the topics, right? Because I'm going to cover how open source is created, get into the definition, because this is a very important area. Your edge is not mine edge, so we got to understand that. Get into the use cases and the project. So this is fairly straightforward on what I'll talk about, but I'll make three statements which form the basis of my presentation of uniting the framework, right? Statement number one, not all IoT is IIoT, okay, which is industrial IoT. Statement number 2, not all IoT is edge, okay? And statement number 3, not all edge is created equal, okay? Primarily, it could be physical constraints, market constraint, use case differences, messaging protocols, a whole set of different reasons. And I think you are fine with that because you got to unite frameworks on things that are common. And what is common? It's the lifecycle management. I hate to say it, it's the boring part of software. It's the plumbing. Let open source and Linux Foundation help you do the plumbing. Not everybody needs to do onboarding of apps. Not everybody needs to do plumbing differently. Not everybody needs to have different set of APIs. Not everybody needs to do cloud connectivity differently, right? And most importantly, not everybody needs to have different terminologies. So let's dive right into how we enable these solutions for that. Very simple. For people who are trying to learn how open source operates, here's a very simple diagram. We at the Linux Foundation and many other foundations, we host projects. Projects are required to complete the development lifecycle, right? And markets to adopt. So we create, develop, manage neutral governance and create the developer community. Anybody can participate, okay? All of you guys that are attending, all of you folks, right? All over the world can participate. They can join and they can contribute. That community creates software and technology that go into a product. And you saw Jim's presentation where he actually used a project called SX Foundry into their commercial products and in IoTech and sort of pushed it out into their customers, right? So the products go into deployment. Deployment make end user markets happen. Everybody makes money. Money gets invested back into projects through people, hardware, new ideas, etc. And the cycle repeats itself, right? We're talking about the non-differentiated part of the software community. So if given that, what are the edges and how do you define it? So this is a very simple diagram, and I want to highlight, the various types of edges, right? I'll start very high and I'll get into the definition and how we came to that definition. There's the enterprise and the IIoT side of things, and then there's the home side of things, right? They come into some form of a telco network. Obviously 5G is a big pusher for IoT and edge because of the low latency it gets you, and then into some sort of a telco smart office, right? Keep in mind, there are 3 attributes of edge. It's the proximity of compute and storage. It's the responsiveness. This is a new dimension, and we have quantified it. Anything that is within 20 milliseconds of latency, 5 to 20, can be categorized as an edge application, right? If a sensor wakes up and dumps data into an Amazon cloud every week, it's an IoT application, but it's not an edge application. So just keep that in mind as I said my 3 principles in the front. And then a third dimension of an edge is mobility. As connected cars, augmented reality, virtual things go around into 360 views and things like that. Mobility is extremely important. So what we have seen is these are the industries that have really focused on edge as a key enabler for their business. And this is, by the way, in the order of priority, okay? Not that, healthcare being at the bottom is not important, but it is going to take time given the regulations. Same thing with smart cities, right? And building automations and things like that. But industrial manufacturing, oil and gas, retail, home, etc. Very fast moving industries to take advantage of the edge, okay? So let's get to the definition. This is a very important chart. I'm sure I'm hearing sound clicks of screenshots of this slide. So, you better do it if you want to go and read it. But let me explain this slide. Starting at the bottom, if you double click on what I said, right, there's 2 macro edges, right? There's the user edge and there's the service provider edge. Right, the user edge is generally dedicated and operated by the user, and then the service provider edge is generally shared some sort of an XaaS type, right? And it bleeds in. It's not a hard cut. The hard cut is really the black line in the middle, which is the last mile, or the bar, which is the last mile, right? And so if you go inside a user edge, I think most of our presenters mentioned, some said microcontrollers, some said gateways, right? At the end of the day, there are three types of devices, right? There is the extreme left, which is constrained device edge, right? Memory constrained, location constrained, etc. These are typically microcontroller based, very specific to an industry or a vertical, okay? And a lot with embedded compute. And then you move up, you now have a smart device edge where, it could be a little bit more rugged. It could be a gateway, it could be a server. It's generally semi-secure, okay? And then you get into an on-prem gateway type data center where, you got secure, you got space, you got, things like that. But again, user controlled on that side. Move across the last mile, now you get into the access edge, right? Where you have an edge below a base station, and with 5G connectivity with 1/10 the latency, you're really assuming that you're getting responsiveness of a data center right at the tips of your app. And then you move into the aggregation layer. Anything after that crosses, goes beyond 20 milliseconds, and they're not edge candidates. Okay, so on top, what we do. And by the way, this definition has been created by one of our own projects called State of the Edge, which has a glossary project in it. And that project basically is a Wikipedia style definition of these terminologies. And we just issued, we'll be issuing a white paper on this whole definition. And it's by the community, vendor neutral. So how do we help? We help with projects. So these are names of the projects and their rough use cases and where they belong, right? So I'll start with stage 3 projects, which are really high impact, very mature project. EdgeX Foundry, I think we talked about that a little bit. It's an IoT framework, and I'll show you some use cases on that. Akraino Edge Stack is both a telco use case project, but also it brings a blueprint concept, which is an end-to-end declarative configuration for that. And then you have a series of other projects, which are growth projects and impact projects that each fall in the various categories, whether it's a constrained environment, Fledge comes in there, a home environment, it's a home edge, or an on-prem virtualization environment, which is an Eve project, or a cloud environment, which is Beetle or Open Horizon. So I won't go into the details of each of these projects, but if you look at it from a left to right perspective, it's very important to see it in context of other projects, right? So you got on the telco side, you have Open RAN that comes into an Akraino, into projects like ONAP, Kubernetes, OPNFV. So this is all zero touch automation for the telco side of things. Then you have the enterprise and the edge side of things. And by the way, the good news with open source is standards and consortiums work very closely with us, right? Whether it's ETSI, MEC, ACC, which is the automotive edge computing, or the IIC. And so if there is a standard, it'll be implemented in open source. If there's no standard, it'll be coded first and upstreamed into the open source community, okay? So here's the use cases. And I won't go into all of it, but things like anomaly detection, surveillance, right at the home edge level. Things like radio edge cloud below a base station, or connected vehicle, or augmented reality classrooms, right? Or private LTE services. That's an Akraino use case, right? Or EdgeX Foundry, building automation, industrial process control, smart cities, water, retail is very important on that. Fledge, more in the constrained environment for IoT, predictive maintenance, turbines, transformers, PERM, pumps. We even have TensorFlow integration with MLAI for those apps, right? And then DevOps at scale for Eve. So these are just some examples of the use cases that are, being actively coded, deployed, worked by a very large community. There's a landscape that is being developed. If you're not on it, please work through the TSC and the community to get added. This is always evolving landscape. If you look at the players and the ecosystem, over 80 members here, with a very wide cross section of premium members, because we are focusing on cloud agnostic, silicon agnostic, OS agnostic, right? Open source. So you have a whole series of various players across the globe participating. The good news is, it is very active community, right? Huge increase in the number of developers. And I have to, really thank everybody. Now my theory is in this pandemic times, times of these pandemic, work is the best form of distraction. So we're seeing developers very, very active on our open source projects, right, in the last quarter. We've seen member increases, project increases, deployment increases. When I made the slide, it had 4.3 million downloads on EdgeX. Now I think we're up to 6 now, over 6. So very, very active. Let's keep going. Please participate in it. And the way you do it is, I'll talk about that at the very end. But summary on my talk and the whole session, right, which is there is open source to help you out with the common plumbing problems, but we have to harmonize it across an IoT edge, enterprise edge, cloud edge, and telecom edge. It's a horizontal section. Keep it open and interoperable, whether it's silicon, hardware, etc. Bring SDOs and consortiums together so that you're not fragmenting the ecosystem, and work with other projects. Okay, so with that said, I would probably say, here's how you join. Get a Linux Foundation ID, go to LF Edge Wiki, and just participate, okay? And become a member, just send me a note. It's ajoshapura@linuxfoundation.org. Back to you, Greg.
Great, thank you, Arpit. That was enlightening. A couple questions from my standpoint too. We're going to transition into the Q&A session here, so I won't monopolize the conversation any further because we've got a tremendous amount of engagement. And just to point that out, we're going to try and work through all the questions that you in the audience. So thank you for the participation. If we don't get to all of them, we are going to, IIoT World is either going to post something and publish something after the fact. And as always, we'll continue the dialogue on in the social platforms. And if you want to submit and you missed it earlier, you can do so here in the Q&A. You can submit it by hashtag IIoT World Days. It's plural, IIoT WORLD-DAYS. And there's been a couple questions that have come up. The materials will be made available post-conference as well. So stay tuned for that. Everyone that's attending will get some piece of follow-up from the presentations that have been shared. So that being said, let's dive into the Q&A here. I think first and foremost, I've received 16 orders already for your goggles, Craig. So you may want to jump on Amazon. We can do some fulfillment there. No, all kidding aside, actually, I think some of you guys are still muted, so you might want to take a look at that too. Come off of mute. Maybe if we kick this off, let's see. Hugo has a question for us. Is talking of embedded hardware, sounds like the minimum requirements for a Raspberry Pi. Is there something smaller? There are something smaller microcontrollers, or Linux is a requirement always. So I think what he's asking is Linux a requirement on Raspberry Pis or some of those small control devices? If anyone wants to comment on that.
Hi, Hugo. I can take a stab at that. I saw your question, and I wasn't quite sure if your question was geared to a specific part as far as one of the talks were concerned. For example, Goran's talk on applying some of the AI at the edge, or just generally, or if you're looking at management. I definitely think that you see solutions out there that are addressing microcontrollers, that are addressing smaller systems. The problem has unique challenges. I know at IoTech, we've had to develop an EdgeX-like solution that goes down to the microcontroller level. And when we look at things like management of those systems, there are unique challenges there. Just the OS and what's available in terms of firmware is not the same, as you're probably well aware. So management of those solutions usually happens at one layer up at something like the gateway. But I don't think anybody that's in this space can ignore that. There are too many solutions already out there, and when you look at the brownfield deployments you have to work with, you have to find solutions that wedge your way down to that level. they may not always be as open as some of the other solutions, and that's just based on the nature of the type of technology that's there.
Okay, thank you. If you have something further, Hugo, please please shoot us back another adder to that question, if you will. Got one here for Goran. This is from Nakiran. I hope I'm pronouncing your name correctly. This is whether time series data can be handled by stack encoders in deep learning.
Yeah, I'm afraid I'm not the right person to answer that. My ML knowledge is not that deep. I mean, we focus on deployment of models. We don't develop models ourselves. Spontaneously, I would say yes, but I think someone who is more of an expert in developing machine learning models needs to answer that.
Perfect. Anyone else want to comment? Otherwise, we'll poll the community, and someone may be able to circle back to you, Kieran. Thank you for submitting. See, I had another question here for maybe Jim. If you want to just clarify a little bit, we toss around the word device a lot. What is a device in terms, in the context of edge management?
Boy, that is a great question, Craig. And every time we have any kind of conversation we first try to get their answer to that. That's why you'll hear, usually in the talks I give, I talk about things like nodes and sensors, because device is an overused term, unfortunately, in our industry. Some people refer to the device as the platform which you're going to be running your software. So, it would be things like your gateway. If you're moving up the stacks someplace else, the node in your fog might be the device. Others are thinking about device as the actual sensor, the thing. So I think there are multiple terms. It really it behooves everybody when you're in a conversation to get that definition out in front with the folks that you're talking to, because you will find variants there. So I'm going to try to not define it for everybody in the world, but we'll say that it can be anything from the sensor for some, a sensor or thing, all the way up to the platforms that we're running our edge applications on, and everything in between. So seek your definition from those you're talking with.
And I would add, Jim, like LF Edge has taken a stab at it through the community, through the State of the Edge report. So, the slide I presented is available on the wiki itself, right? Which goes in and clarifies the terminology, because it's come from a community of edge players and more than that. So I think we're getting to a point where I think terminologies are getting aligned. Yes, I agree it was a challenge, but I think we're getting better on that one. And that was a slide I told you to take a picture of.
Oh, thanks, Arpit. I want to grab another comment based off of what you just said as well. So maybe clear up some more vernacular, or hopefully not make it more nebulous. You throw around the terms too. You've got fog, edge. Is there any kind of a formal definition, and I would love each of your responses on this, for the difference between the two, or a delineation?
So both of these terminologies, including other terminologies, right? Like there's, it's all discussed under the project Glossary, which is an open source project under State of the Edge. And the beauty of that is anybody, not just developers, right? A press, an analyst, or anybody can go in and make a pull request and say, I don't like this definition. And then the TSC and the community will review it and append it, right? But it has a very clear definition of what fog is, what edge is. I think more and more community is using, edge and its various types more now, just given where things are, and I would say the fog is settling down and edge is clearing up.
Got it. Okay. Let's see. Rockio is asking us what the collective opinion is of Google Coral, Edge TPU, and NVIDIA's Jetson family as edge technologies. I don't know. Anyone have a perspective on those?
I don't think we should comment on any specific vendor implementation here on a generic panel. But TPUs and accelerations in general are a big booster to any edge application. And the price performance packaging ratio has gone in very, very nicely to enable, I think, as Goran said, right, a lot of analytics at the edge are possible because of these advances. So, all heading in the right direction to enable the edge market.
And I would agree, commenting on an individual accelerator or vendor package is probably not the best, because there's just so many of them. One thing I can say for both Google and it seems like every major cloud vendor has an acceleration package, and they are including a lot of open source elements into those packages. So that just tells me that they themselves see that even with the packages and edge devices that they're deploying now, that there's more that their single delivery can address. So they're looking to include open source application software packages into their accelerators to kind of broaden their environment, their landscape of what they can touch and communicate with.
Okay, Rocky, if you've got a specific application in mind or something that you want to delve into, it would be more of a broader sweeping question. Happy to take another crack at that. Okay, how is the governing of open source evolution in the Linux Foundation communities different from Apache?
Yeah. All right. So good question. The good news is, we have several of these foundations enabling open source, whether it's the Apache Foundation or the Linux Foundation, etc. The governance is always neutral, right? Meaning, it's not a vendor-led community. It's not a single dominant type thing. So all of the charters and all of the governance is written down and published on the website, right? There are some fine differences, but in general, they're all similar. In fact, some of the licenses used for code are quite similar, like Linux Foundation. Several of these projects use Apache 2.0 license, right, for example. So I would say the difference is really coming across on the project categories, right, where the foundations have chosen to focus and which projects come up where, and the community forming around it. And most of the times it's complementary. So we work closely with pretty much all the foundations.
Okay, we got another question here from Christopher. This is, why assign a latency requirement to your edge definition? And how did you come to define the current range?
So this is actually several years of research by several of the telcos as they were developing 3G, 4G, 5G, plus an overlay of edge applications beyond IIoT, right? So IIoT is one element, as I said, of edge. As we got into connected cars, as we got into AR, VR, as we got into applications like, drones, doing base station inspections and sending analytic signals back, and, lots of these new innovative applications, they realized that in order to be effective, whether you're doing, effective for an action, right? Whether you're doing a predictive maintenance, or whether you're shutting down something, or whether you are guiding a car or an autonomous truck driving, there is a minimum set of latency that is required for that application to effectively do its job. And I think that research has basically gotten us to this general range. Okay. Now, I'm not saying 25 is not an edge, and 2 is like ultra edge and all that. So but this is the general guideline that we have been receiving, and our community has been saying. So that's where we came about.
Okay, we've got a couple questions. I don't know if I can combine these or not, but the topic of security is coming up. So Eric's asking, one of the main concerns around IoT in general is security. What is the open source solution for security or approach? Or how do we address that from an open source?
I can start, and maybe we can add, right? So there are 3 parts to security, right? Because the assumption here is, so there's the physical security, you cannot guarantee, and I think in my definition slide, I said, semi-secure location. That means physically, you cannot guarantee security. So there's that aspect, okay? Then there is the aspect of, cybersecurity and sort of runtime kind of security. And we'll talk about that in a bit. And then there is the actual security of the code and open source, right? So that's where we focus on at the Linux Foundation in terms of, scans and vulnerability analysis. And, it's a well-proven, I mean, there's been research papers and published material that say open source is more secure, more set of eyes, more scanning, more testing, all of the more things, right? But more than that, we do more formal analysis of CEVs and things like that, along with license scannings and things like that, right? So the code itself, what it does is a different thing, but code itself is more secure than a proprietary closed box solution, right? That you don't know what you're getting. And then on the third part, which I think others can chime in, which is the actual security of the project, you cannot say here's a security project for the edge, right? It has to be embedded in every project. With an assumption that you may not have connectivity, with an assumption that you could be booting, resetting and booting and getting in through hacks and things like that. So a layer of security has been built in. There's no perimeter, right? So it's built into all these software projects. So I'll sort of just set that context and let others chime in.
Yeah, I think from our projects, I couldn't agree more. It's a layer of security built into each one, and as part of any project, you'll want to validate that security at each layer, be it at your router, at your gateway, at your node. You'll want to go and make sure that those security that the security checks out. There are lots of open source projects and initiatives trying to bring together more of some of the cybersecurity. So there's projects around data exchange. There's projects around just encryption. So there's lots of work that's being done, and you can leverage those projects. But we always encourage the idea that it is built in, and you'll want to go through and validate it at each level. And to that, we concur with the idea that doing those scans and having an open security model lets you, we go as far as to say having an open security model kind of points to the idea if there are vulnerabilities in it. In open source, you find those vulnerabilities a lot quicker, a lot faster. They're a lot more known than in a closed product, in a closed commercial product. So it makes it easier for us to kind of showcase where the security is, if there's a vulnerability, looking back over the history of it, and where there might be some efforts, if at all needed, to augment it for a particular use case.
The studio's got kind of a layered question on this as well. It says it's basically around responsibility. Is it become the responsibility of the open source community in terms of the security aspects of it, or does that fall in manufacturer? Where does that teeter-totter tip? Okay.
Well, I could take a little bit of a shot at that. I think the answer is it depends on all of us. Security is a multifaceted problem with multifaceted solutions, and you can certainly look to an open source community to try to do things in as secure a way as possible. And as both Arpit and Craig said, the open source community at least does things in the open, as the name implies, and so everybody has a way to kind of put eyes on and try to build the best of solutions out there. But in the end, companies are going to put solutions in place. They're going to always have to take open source and to some extent take pieces of it and modify it for their own needs, their own use cases. And they're going to be involved in certain use cases that have threat avenues that, frankly, some of the open source projects wouldn't have ever thought about or dreamed of. If I hope in a recorded session like this is going to be probably setting me up for problems. But as you look at the world today, if I was somebody who was nefarious and trying to break into systems today, there are a lot of different avenues in an IoT solution and an edge solution that I can try to take advantage of that aren't there in other solutions. And those are being hit pretty hard today. And so the problem is a difficult one. It's really going to take everybody to help kind of address them, and address them in ways that are unique to the edge.
Very well, thank you. Shift gears a little bit then. We've got another question coming in. What's the real latency on 5G? And how can the carrier provide UPS power to a microcell? Arpit, do you want to?
Yeah, sure. So I think the general average latency, if you look at today's network, which is all 4G, is roughly around 50 milliseconds. And with 5G, you're going to get that down to 1 millisecond. Okay, so that's the beauty of low latency, right? It's not just faster phones and faster YouTube videos, right, that we will enjoy. This is where the industrial IoT and the markets that are relying on kind of data center to the edge, right, is what's going to sort of proliferate. I do believe carriers provide the UPS power on microcells, right? There are some vendors that do that. Depends on different carriers, so I think it's a longer answer than that. But yeah, there are options and opportunities for that to happen.
Very good. Now, Eric's got a follow up on this. He says, on the security topic, is there a way to raise security events that can be sent to an enterprise SEIM solution? Does anyone have any knowledge base on that?
I can start. So if SIMs are deployed in an enterprise data center, and that data center is a large manufacturing data center that also hosts the on-prem edge, as we called it, right? Then yes, a lot of the smaller devices, right, typically don't do that. They typically just analyze whatever needs to be analyzed and then dump it out into a central cloud or something like that. But yeah, I mean, if it's a large enough enterprise with their own data center with existing SIM solutions, then you can do it.
Yeah, I was just going to add that we've actually built in just some additional features, but it generally is based on more of the size of the deployment and where kind of the where all of the deployment components sit. And if you do have a present SIM solution, yes, you can actually do that. And there's lots of different, there's already some open source pieces that can allow you to do that, or you can really kind of work through and do your own, kind of depending on what events you're looking to capture.
All right, thank you, Craig. Thank you both. A quick question from Vimal here. He says, to Craig, can you store metadata in a database like Influx?
I generally, the short answer is you can. I generally don't recommend that, and that's because especially when you're talking about working with data, in IoT and sharing it, what Influx really wants to focus on is that share of your time series data. So as I listen to kind of all of the other some of the other talks, we really want to be that specialized platform for being able to process, ingest, query that data. And your metadata related to anything else referring to devices and nodes, keep that in a store that allows you to leverage it. Through Influx, you can access those meta stores. So you can query them, you can write directly to them. So we have methods and features and functions that allow kind of that data exchange. But what we really want to focus on is being that purpose-built setup for your time series data for machine learning, for anomaly detection, for processing, for reporting, and then let other platforms focus on that metadata piece, but allowing you to communicate and move data back and forth between them.
All right, thank you, Craig. Goran, Brian is curious, what are the main challenges of using ML at the edge? If you could just expand on that, we touched a little bit in your presentation.
Well, I think if we look at today, there are two main challenges, and one is maybe not edge specific, but I mean the lack of pre-built, or maybe I should start in another angle. I would say the lack of data scientist skills at least within our customer base, which is typically the industrial users. That is the main challenge today, and since there are very few, if any, pre-built modules that addresses typical use cases in this space, you have to rely on your own data scientists to develop models for for these use cases, and especially smaller companies that they typically don't have those kind of resources. So that is the main blocker to get started with machine learning for them today. So I really hope that we will start seeing more of those, preferably pre-built models for common use cases, or at least tools that doesn't need the same kind of skills that is required by many of the tools that are out there today, which are pretty advanced. Second thing, which is more edge related, is I addressed part of that in my presentation. It's about the execution environment. I mean, what we see today is that in almost all cases, you have to replicate the same environment that was used for training, which is typically not optimized for being used at the edge. And also you have to replicate the same environment in the edge. So you need to know which environment that was used and set up the same thing in the edge. So it would be a lot easier for everyone if we could start using more generic execution environments at the edge that are both optimized for the edge and also where you decouple the execution environment from the training and model development environment. So those two things I think are challenges today, but hopefully something that will be addressed in the not too distant future.
Thank you, Goran. We've got a question. One of probably the largest mandate of IoT world from our board and our mission is to expand the perpetuation of the industrial IoTs. How do we spread this and keep this moving? So how do we accelerate edge deployments in terms of open source? I'd love to hear your perspective, Arpit, as well as the rest of the panelists on that too.
Yeah, so I think, as I said in my circle, right? We are at a point where, and this is no different from other open source projects we host, right? It happened in, Kubernetes, it happened in open networking automation platform, our own app for the telcos, right? It's happened in Open Daylight. Right? What happens is everybody says open source is the way to solve it. So let's fire up about 100 projects on open source, right? Now, all of a sudden there is confusion in the marketplace. And then each industry fires up their own, because it's, you can put any project on, you can open source your code and put it on GitHub and say, I'm open, and go, good luck with that. Most of these projects die, okay? Because the fundamental things that you need to develop on that is a neutral governance and a community, okay? And the community will only develop if the project has value. And the project has value if you have developers, participants, end users that know that this project is going to be successful, okay? So I'm just giving you, 5, 10, 15 years of, our Linux and all our experiences, right? In 2 seconds. But the point here is, once you have a harmonized, unified open source, right? Let's not all say my project is better than yours, because at the end of the day, nobody's going to make money out of these projects, right? These is the plumbing non-differentiated layer. This is the boring part where it's shared innovation or shared IP that we all create to make our differentiation on top. So that's the first step. I think to get deployments and all, we are very excited with, now LF Edge umbrella is now in the 2nd year, and we've seen a huge growth, as I showed. So people are coming together to participate, contribute, and then, players like Jim and his company and a whole bunch of others, when they start using it to make commercial products and solve use cases, now you've seen the whole cycle. So I think we are in the final phase this year where, everything is coming together at the right moment, and we're seeing the adoption very, very significantly.
No, thank you. Does anyone else want to comment on that?
I would say, in addition to that, we're seeing a lot of growth in just the deployment of open source. Actually, partnering with even larger cloud CSPs. Working with the likes of Google, with Azure. You wouldn't think they would be your natural open source allies, as Arpit just mentioned. It's not about one project being better than another. It's really about all of us coming together to produce these solutions, to produce these frameworks, and then they work themselves into commercial areas. But we're even seeing the interest come from some of the largest players and really kind of working into their area. And that's actually accelerating a lot of use we see with some open source projects and applications specifically. So I think as you continue to even work with, you know, those large vendors, you're going to start seeing elements of open source being sprinkled throughout. And that's also going to accelerate more use of those of various projects and bringing them into it.
Thank you, Craig.
Yeah, I'll add on top of that a little bit too, in that when you look at the world, right, there is already a growth in edge and IoT needs out there. It's been a little bit time coming for organizations finally kind of get a grip on what their actual requirements are. Open source will follow that trajectory. They are elements of the solution in any space we think about with regard to our world, and it will be a place for open source in this edge and IoT world. I think Craig said it in his opening. Companies, organizations are looking for solutions, however, and sometimes right now, some of the open source technology we have are pieces to the solutions. So it's taking time for some of the companies out there to start to stitch together those pieces into more cohesive solutions that people are looking for, but it will happen. It's just natural.
No, good perspective. Thank you all for that. So we're coming to the end of the session. I've got one more question. This came in from Rakio. It says, what communications protocol is mostly used? There's a reason for that. So
pick your favorite from the 170 plus that exists. Based on markets, vertical constraints, connectivity, you know, as we said, there's many factors that go in. I think that's irrelevant in the bigger scheme of things when you get to the software part of it, right? But I'll let the experts answer it.
I think that's right on, Arpit. You know, it's really not so much as what is mostly used, it's what do you encounter when you try to put together your solution. If you're in a factory, you're going to see lots of Modbus. If you're in a building automation circumstance, you're going to see lots of BACnet. It is just part and nature of what we have to deal with. The protocols go with the use case. So what is your use case? That's what you're going to encounter. Certainly there's still a lot of HTTP and MQTT and things of that nature out there as there would be even in enterprise, but the IoT edge solutions will have protocols that some of us in our careers have probably never encountered, and that's the joy and kind of the fun of it, but also the complexity of it.
Well, the key is the lifecycle management software and the open source frameworks that come, they ignore it. They're abstracted, right? Because you can't have all the modules that are based on protocols, right? That's just drivers at the very similar. Think of it like device driver abstraction, right? Here's protocol abstraction. You just do it.
And I think just to add my last point, and I couldn't agree more with all the speakers. You know, we see open source as being able to being the idea for addressing those hundreds of protocols that, you know, when we go in, it's always a protocol. There's protocols that may seem more popular, but there's always something I've never seen in my career. And what we'll find is that through open source, you know, we can start to address a lot of the protocols that were either really restricted or locked into a particular vendor and kind of open them up. So I see open source as another answer to, you know, what's your protocol today? Well, open source will come up with something for you.
Outstanding. Well, I think that brings us to the top of the close of the session. So on behalf of IIoT World and our audience, I want to thank everyone, Arpit, Goran, Craig, Jim, fantastic input, great insights. Thank you for sharing your expertise with us. This would not have been possible with this virtual conference and the entire session without our sponsorship. So special thanks to Influx Data for making this track a reality. Please enjoy the rest of your sessions throughout the balance of the day. We've got some tremendous content left that's building here. So please stay tuned, log into those ones that are left throughout the afternoon. And also stay aware and watch our outreach for additional conferences that are going on later in the year. We have a September 3rd session on machine learning and artificial intelligence in manufacturing. September 23rd, there's an industrial IoT in manufacturing. We also have October 8th, there's an Industrial Cybersecurity Day that IIoT World is going to be sponsoring. So more details will be provided in the upcoming months, so stay tuned and pay close attention to our newsletter there. If you have a suggestion for a topic or otherwise, we always welcome feedback, so drop us a line and give us your information. If you like what you heard today, we'd invite you to sign up and follow us through our newsletters, our social media feeds, YouTube, and our Twitter channel at IIoT World. So please, I hope you enjoyed the session and joining us today, and this concludes the track. Take care, everyone.